the Java architects. We have two Java architects here. Introduce yourself.
I'm Brian Goetz.
I'm Mark Reinhold. We both work on Java. So the way this works is it's a Q&A session. First, I have to show you one of the few other slides in this very short deck. Don't believe a word we say. Okay, lawyers are happy. This is Q&A. We have a microphone here. We ask for the recording that you please come to the front to ask your question. Please keep it to questions, not comments. And we will do your best to answer them. If you are shy, or I don't know, is there a live stream of this? Maybe. Let's not say. If hypothetically speaking, there's a live stream, and you're watching that live stream, you can ask questions via Twitter using this hashtag, and through the magic of the internet, I will look at the Twitter now and then and draw questions from there as well. Did I forget anything?
I think it's their turn.
All right. 1, 2, 3, go. Don't all jump up at once.
First one's the hardest.
Okay, well,
yeah. Someone must have come to a session called Ask the Architects with a question in mind.
What would be a good question to ask?
What would be a good question to ask?
don't be afraid.
Yeah. Come on up to the microphone.
We don't bite.
Brave man. We would hear you, but the camera wouldn't.
I have a very simple question just to start with. I mean, Oracle has started this 6-month release. I mean, it might be a very common question to ask, but what's the idea behind it?
What's the idea? Let's see. The idea behind the 6-month release is, well, there are multiple motivations. One motivation is to deliver features to all of you more quickly, right? In the previous slow cadence where we delivered things every now and then, maybe every 3-5 years, one time a little longer, sadly. Those big releases would be driven by one or a couple big features. And if one of those big features needed more time, then the release would slip. And the whole thing would be unpredictable. In the meantime, there were other smaller features that people were busily working on, and they were done, but they were done like here. But nobody could use them because the release didn't actually ship until here. So with a 6-month cadence, when a feature's done, it goes in and it's on the next 6-month train, and out it goes, and you can use it. And we've already seen the fruits of this since we started this a little over a year ago. So that's probably the biggest motivation. Another motivation, well, another benefit, I should say, is kind of a motivation, but the benefit turned out to be, I think, bigger than any of us imagined, is the pressure on and the tension on all of us contributors, both inside and outside of Oracle, working on one of these releases is really low. It's incredible. It's like, oh, we're doing another release. Cool. Yeah, great. You're working on a feature. Is it done? Oh yeah, I know this release is coming up. Is it done? No, it's not done, but that's okay because the next one's just 6 months away. You're not playing as one of the best managers I ever had. A son used to say, don't play chicken with the date. You're not playing chicken with the date. You're shipping features when they're ready, rather than trying to ship them when the release is going to go, because it's going to be 3, 4, 5 years. You don't know how many before the next feature release. So that's a big win as well. So I think it's worked out fairly well, and you have a choice. You can upgrade every 6 months if you want the latest and greatest features, or if you don't want to do that, you can stay on the long-term support releases, which come out every 3 years, and migrate at a more stately, calmer pace. It's up to you. If you do stay on, if you deploy on the long-term support releases, an important piece of advice I would give you is still test with every 6-month release. That way you spread out migration pain over time. By the time the next LTS comes around, you'll be practically ready. You won't have to schedule a bunch of time to deal with 3 years worth of change in the platform. You'll be nearly there.
And another sort of hidden benefit that we didn't realize at the time, we were mostly focused on more frequent opportunities to deliver value and avoiding the kinds of distortions that Mark was talking about when you get up to the deadline and you think, oh my God, I got to get this in, and that causes you to either look the other way on quality issues, or fool yourself that you can finish it, and you work 80 hours a week and you burn yourself out. And we saw that as a problem, and we wanted to fix that. But one of the things we didn't realize was it gave us an opportunity to rethink our feature mix. So we had, when you have a big 3-year release, it's natural to focus on the big thing that's going in that release, generics, lambdas, modules, and you put all your energy on that because that's the big release driver and you want to make sure that it's a success. And so littler features like local variable type inference somehow don't even seem worth doing in the context of a big multi-year release. And so we didn't do a lot of those features, and I think we over-rotated towards the big disruptive features that that make big changes to the whole platform, like generics or lambdas or modules. And with releasing more frequently, I think we've found a better mix of working on big things, which take many years, and we don't force ourselves to work on a feature for 6 months only. But we have a better balance between big ongoing things and smaller things that we can release relatively quickly, and I think that's worked out really well.
Yeah, and even those big things, looking at some of them in retrospect, in Jigsaw, the modules, that Jigsaw came into 9 in 3 big phases. We could have done each with a little more work. We could have made those phases sufficiently independent that each could have been in a different 6-month release.
Yeah. So so one of the things that we're learning now, and we haven't, it takes some time to learn these things, but one of the things that we're learning is how to break some of these bigger features up into smaller, releasable, lower risk chunks, and lay some of the groundwork for some of the pieces that we know are coming in the future. I mean, one of the big challenges with Jigsaw was that there was some disruption, and it took a certain amount of time for the ecosystem to absorb it. And if we were able to break it up where there would be warnings a year ahead of the disruptive feature, then more of the libraries would have been ready by the time the disruption actually happens. And that's, looking back, it seems sort of obvious, why didn't we do this 10 years ago? But, the thing that I like is the part that Mark said, which is we spend so much less time on the mechanics of planning and tracking releases and a lot more of our time doing engineering work. And I really like that part.
And as our manager colleague over here often likes to point out, one of the advantages of doing things every 6 months is you get really good at it.
Yeah.
It just becomes you've got some checklists. You just go through it. You turn the crank every 6 months. It's out the door. When you're doing a 3 or 5 year release, like you get around to a few months before GA, and it's like, oh wait a minute, there was some other process we had to do here, and what was it? And are we forgetting something? And you have to go back. But you really automate things and just get everything running smoothly.
Uh-oh, George is going to have
So now I can't be anonymous anymore because you've waved at me. Hi, folks. So, hey, in the past, these major releases were always a big event and took a really long time to uptake, right? It could be years. So aren't you worried that that's going to happen with these 6-month releases?
Well, that was a softball, wasn't it? So the reality is, the Java ecosystem is enormous, and you have a big variety of customers and user profiles, and you've got some people who always want to be on the bleeding edge. In fact, they don't want to wait for the release; they want to check it out of the tip from Open JDK and deploy on that. And then you've got customers that don't want to upgrade until it's been in production for 10 years.
They're still on JDK 6.
And they're still on JDK 6, and they're thinking maybe about moving to JDK 7 someday, right? And these are all Java users, right? And they have different trade-offs of innovation versus stability, and having the combination of frequent feature releases so that the bleeding edge adopters can stay on the train and get the benefit of the innovation that goes into the platform as soon as they can, and they're happy. and then we have stable long-term release, for the enterprise customers, I think it sort of balances out the tensions in the community.
Yeah, focusing on the Jigsaw part of the upgrade to 9 and 11. As someone that's just migrated from Java 8 to Java 11 with a fair amount of third-party libraries, noticed that far from all of them has even started on migrating to Jigsaw modules. Are you happy with how the community has adapted to the new system and the speed of this? Feels like some parts is not up to speed at all from my point of view, but how do you see it?
Is your question about the migration to 11 or about the adoption of Jigsaw?
To Jigsaw, yeah,
Okay.
because that's the most breaking part of it.
Right. Well, although it's largely the breakage due to Jigsaw that causes the pain of migrating to 11. So we always knew going in that was going to be an issue, but we thought, and I still think this was the right decision. It was a modularizing and encapsulating the internals of the platform was a necessary move to make it more maintainable, to get it ready for the future. We knew that was going to break some things. We tried to do it with as much input as we could, with as much analysis of large code bases as we could. But it was unavoidable. You're going to clarify your question?
Yes, I'm not against the switch at all. It's more like the speed of adaptation to this.
Right.
It feels like someone's waited a long time with even starting with this migration.
Yeah, okay, so
it's more that, not a criticism to the switch. That's
Sure.
I like the module
great.
system.
So I was just about to say, so we knew going in it was going to be, there was going to be more pain than usual. We never expected migration past 8, going from 8 to 9, everything 8 to 11, whatever, to be as fast as, say going from 7 to 8 was. That was relatively simple. But things are moving along. In the keynote talk I'll give tomorrow, I show this result. I did a poll on Twitter right after 9 shipped. Asking people, if you maintain a popular library, framework, or tool and it works on 9 today, then let me know. And I got 90 some responses of things that just worked, including a lot of the usual popular tools and libraries. And I did the same after we shipped 11 in September, and also got a very positive response. So, active maintainers of libraries are definitely looking at the new releases. They're testing. They're making small changes if they need to. And that's great. As to the adoption of Jigsaw itself, we've seen that's another thing that we always knew would be slow, right? We designed Java modules so that there would be something that would have a clear migration path, but it does take some work to go down that path. We always knew it would be slow, but there has been good, steady progress. If you know Stephen Colborn, he maintains a page on GitHub, I forget exactly where it is, that links to some data that he collects automatically from Maven Central to gauge the number of libraries that have actually been, either have taken the first step towards being modules, which involves declaring an automatic module name, or taken the second bigger step to actually turn it into a true module by having a module info.java file in the source code and compiling the module descriptor and everything. And last time I looked a couple of weeks ago, that number's pushing 4,000. So there's just been steady progress there. And some people like to hate on it and say, oh well, nobody's adopting it, it's never going to be popular. But there's this steady progress, it's happening. We always knew it would be slow. We said it would be slow. It's happening. I think it will. I see no reason why it won't continue.
And I think one of the things that will help accelerate it is improved tooling support, right? So if you maintain a library, you are more likely to modularize it if there's good modularization support in Maven and in your IDE and such. And so, and there's necessarily a certain amount of, time lag between the time that we ship modules in the JDK and, first of all, for Maven to even work with that version of the JDK, and then for Maven to support you in a workflow building modular libraries and applications. And so there's been a lot of progress recently on the tooling front where the tools are starting to, to complete their story.
Actually, sorry, but I think you're underselling it. So in the development of Jigsaw, even before 9 shipped, we worked very closely with the Maven maintainers. We worked closely with the IDE makers, IntelliJ and Eclipse, to get at least basic support for modular projects into all of those tools, and they have since improved even more.
Yeah.
So and we try to do that all the time. When Brian and the team are working on a new language feature, they'll help out the IDEs, so the IDEs have the support really quickly.
And I think the elephant in the room with respect to libraries that are not keeping up is the fact that there are libraries out there that are simply unmaintained. And a change like this is something that shines a flashlight in the dark corners where we discover that libraries on which many people depend turned out to be completely unmaintained. And it's unfortunate, but it's at least good to find that out. And then the community can figure out, well, does someone want to step up and maintain this thing, or should someone build a replacement or something like that? But I think there's always going to be a big tail of stuff that never gets there because the maintainer got interested in something else 10 years ago, and the code, and it's been mostly working since then, so we didn't notice.
Yep. All right, a couple of questions from Twitter. Here's a quick one. Fibers will be available in Java 12. Well, let's see. They're not in Java 12 today. The first release candidate is next Thursday. I think the answer is no. Features ship when they're ready. Fibers are not ready. They're pretty far from ready. I will demo where they are tomorrow. They are working and turning over nicely, but there's a fair bit more work to do. Here you go, Brian. How do you feel when people try to push you to include features from other JVM languages into Java? How do you dismiss them?
Just another day at the office. I mean, I don't think a week goes by, where I don't have a handful. Have you thought of this feature? I love this feature from this language. Are you doing this feature? Why isn't it at the top of the list? And, and so there's like the features that we actually do invest in. And then there's the other 99.9% of the feature ideas that we don't, and typically for one of two reasons. One is because it's a terrible idea. Unfortunately, a lot of the suggestions are, or they're just a bad fit for Java, or they collide with some other feature and that we already have, or something like that. And then there's a lot of features that people suggest that actually are sensible features that we're not working on, and we probably won't work on forever. And people are kind of mystified by why is this? It's like, well, if you think it's a good feature, why aren't you doing it? And the answer is the same thing as when your customers ask you, why don't you have this feature? And the answer is that you have a finite capacity. And we look at this as sort of a budgeting thing, not just and we're not just talking about the budget for engineers and other resources that are needed to make the feature, but we sort of see the language as having a complexity budget. And if we add complexity over here, that constrains our ability to add complexity over there without things collapsing under their own weight. And we feel like we have a budget for asking users to absorb new concepts. Right? That if we throw a lot of new wacky stuff that no one's ever heard of before, they're going to say, "Oh my God, you're making this so complicated. I'm going to go do something else." Right? And so there's a sort of optimal rate at which we can ask users to change their mental models about how Java works. And if we don't do things quickly enough, then the language stagnates and it becomes unattractive, by comparison to other languages. If we change too quickly, we overwhelm people, we risk collapsing under complexity, And so, you know, I think like the example with lambdas is a good one. How many people here like lambdas in Java? So I'm glad to see that.
How many people hate lambdas in Java? Sorry.
Yeah, I'm looking to see if anybody is like kind of rolling their eyes a little bit because they're afraid to put their hand up. But so you know, when we set out to do lambdas, there was a lot of skepticism. There were a lot of people saying, "Oh, you're just following fashion. Oh, the alpha geeks have grabbed the steering wheel and are going to drive us off the road. Java developers will never be able to understand lambdas." I mean, it sounds funny now, but if you look back to the mailing list discussions in like, you know, 2012 or, you know, or so, people were really skeptical that, you know, that we weren't going to break Java. And, you know, there were opportunities to break Java, which fortunately we avoided, you know, good for us. But if we cram too many things in, we're eventually going to break it, and we don't want to do that. Did that answer the question? I think.
Seems
Twitter
to me it
says
does.
yes, right?
Twitter says.
Okay, cool.
Microphone's right here.
So I've been thinking about the role of the VM in microservice architectures. Say that you have a silly microservice, and you have
a what microservice?
a silly microservice, meaning it doesn't do a lot of things. It's a small one. That's why we call it micro.
Yeah.
And you have 5 instances of it, and you have load balancers, etc. And you assign memory to a lot of VMs to drive all that. And it looks to me like we have a lot of overhead, and you have the Docker containers and everything. Now, the situation is improving somewhat with Docker and VM integration, but you could see that this could go 2 ways. Either Docker and the VM grow together and work better and better, so they can get more resource efficient, or we just skip this Docker layer and start deploying microservices directly to a VM function as a, serverless. So if you look very far into the crystal ball, 5 years, where do you think this will go?
It will probably go both ways, or multiple ways. You know, a lot of it is going to depend on all of the, you know, the myriad trade-offs that you find in cloud environments and, you know, the needs of the applications. So, you know, is there a future where people run, you know, a gazillion different microservices on one big JVM, kind of like, you know, people still run apps, you know, app servers with, you know, multiple web apps being serviced by one JVM? Sure, that's totally possible, and it would probably work pretty well. There are also obviously people interested in going the other way and having, you know, one JVM per microservice instance, which can be a fair amount of overhead. But I mean, you know, people talk about the JVM is big and it's slow and it takes a long time to start up, but that's often said in a way that loses the context of what's actually going on when you're deploying something like a function as a service in a Docker container, right? There are overheads to Docker too, right? You know, spinning up a Docker image takes some time. You can get the JVM started up, you know, especially, you know, something recent from, say, JDK 11 or JDK 12. With a little effort, you can use some of the new features to improve startup time. If that's what you need to do. And the reality is, even for in a cloud environment where microservices are coming and going in a functions as a service sort of scenario, you know, systems like what Amazon has, they'll spin up a container for you and they'll keep it around for a while, you know, to see if more requests come in, and eventually it goes idle and they shut it down. They're not spinning up a new Docker container for every single request that comes in, which is the sort of micro benchmark that people like to focus on. So, you know, I think Java can go both ways. I think it's certainly a place where modularity helps. If you are concerned about your your Docker image size or whatever container format you're using. Instead of shipping around a couple hundred megabytes worth of JDK, you can JLink a custom runtime image that just contains the 1, 2, 3 dozen whatever modules that you need. You can even compress that further if you want and have something on the order of tens of megabytes. We've done some additional work in the VM over the last few releases so that the garbage collector, the memory system generally interacts better with container memory constraints for a while. And but before that work, Hotspot was was completely ignorant of being inside a Linux container. Now it can detect when it's inside a Linux container and adjust its memory usage appropriately. So there was a bit of plumbing to do for that. It wasn't particularly hard, but that's in JDK 11. Might have been in 10. I forget.
And I want to drill into the assumption that the JVM is big and heavyweight, and by some measures it is, but that's looking at a snapshot in time, right? So the JVM that we have today has evolved because of the way people want to deploy applications, right? So for a good part of the last decade, the decade before this one, the trend was towards deploying big applications, multiple applications on one application server, separately lifecycled and versioned, and so you had very long-running processes, and it made the natural engineering trade-offs in that environment favored taking startup hits in favor of better asymptotic performance, better throughput, et cetera. And that was just us responding to what the market was demanding. Since then, the fashions of how we like to deploy our applications have changed, and they will change again, and they will change again. I've seen this dance a dozen times in my career because I'm old, and this happens every 5 years. So the things that you're describing as slow and heavy and fat and all of that are artifacts of the trade-offs that were made, a decade ago. But we know how to reduce startup time. We know how to increase sharing by pre-compiling things to shareable libraries that can be shared across multiple containers running on the same system, which reduces both footprint and improves startup time because you can page things right out of memory map files that may already be hot in cache because somebody else has mapped them in. So, these are all standard engineering tricks. There's, this isn't, it hasn't taken us by surprise. So, and at the same time, you will see evolution in the layers above the JVM, right? So you will see serverless containers that will warm start instances and such based on predicted demand so that users aren't exposed to the perception of slow startup. And so I think these are things where the technology lags the fashion by a few years. And usually the technology catches up about in time for the fashion to change, and that's just how the game works. And I have every expectation that that will continue to go that way. So things like application class data sharing, which was a feature that had been a commercial feature that's recently been open sourced, is one of the things that you can do to improve sharing, improve startup, reduce footprint. AOT compilation is another option that has some trade-offs, but that also can improve sharing and reduce startup. And there's more stuff coming in the pipeline. And as Mark said, more awareness on the part of the JVM that it is running a container and respecting memory and CPU limits. These are, there are a lot of small features that work together to get us to the point where the perception is no longer, gee, the JVM is big and fat and heavy.
Two questions, one regarding future. So what is like for you personally, the forthcoming feature that you wish to see released? And regarding past, what is for you personally the most biggest regret that you say maybe we could done this better in Java?
All right, I'll go first. So I am very excited about Project Valhalla. I've been working on it in varying degrees for almost 5 years now. And I would say that even though it sounds like, gee, these guys have been working on it forever and maybe they're never going to get there, we really turned a corner in the last year, and I'm really optimistic about the direction it's going. And I think it has the opportunity to lift up the programming model in surprising ways. So I'm really looking forward to having that in my own hands to program with in terms of the libraries we write, and having everybody in this room having it in their hands, to program with. There's always been trade-offs that library writers face where they end up feeling like they have a choice of do it the right way or the fast way. And whenever you give people that choice, they're going to make the wrong one. And so by making the right way be the fast way, a tremendous amount of friction is removed from the development process. And since I started working on this project, I see that friction now in stark relief every day. I see the degree to which there's this part of my brain saying, oh no, you don't want to do that. And it's distracting, and it keeps you from getting to the goal that you want to get to. So I am really looking forward to that. Regret. Well, so
I know what
yeah,
he's
he knows what I'm going to say, but it's not really my regret. It's more, which is serialization, the gift that keeps on giving. The feature that slows down the development of every single feature that came after it, which is all of them. It is a renewable resource of regret.
Yep. So looking forward, I think I share Brian's view that Valhalla is the most exciting thing. It will be a sea change for the JVM, for the language, for the platform as a whole. So I kind of can't wait. On the other hand, we're going to do it right. We're not shipping it in 13 or anything stupid like that. It's been really exciting to see. Some of the recent work has really just borne fruit, and that you can download a Valhalla build and play with it. And I'll demo this tomorrow in my talk in the morning. You can write a value class, and it compiles and it runs, and it takes up a lot less memory, and it's really cool. So that's the thing I'm most looking forward to. Like Brian, I also find serialization incredibly frustrating. So I won't say that's the thing I most regret having been in Java. Serialization went in, I had just started at Sun. I'd been there for less than a year, and there were raging debates about it. But I was like, this junior guy at the time was like, oh yeah, the people who are against it, they're right. But I wasn't like in a position to help with the argument, and it went in, and there it is. Another thing that I regret looking back, or maybe something that we could have done better, would have been to do modules in about 1998. Because the language and the platform didn't have a notion of modules at that time. Jar files were the only thing. They're not modules. They're collections of classes. It's a little snippet of a class path, and they have all of the problems that we know about. And instead of having modules in the language and sort of native in the platform, people slung jar files around. Tools like Maven grew up around that base architecture. We got Maven Central, and these are all understandable, perfectly understandable, totally justified reactions by the wider ecosystem to the lack of things in the platform at the time. But our collective lives over the last 20 years could have been a lot better if we had modules in the platform around 1998, but we didn't. Sun had other priorities, and that's not what we worked on. Oh well.
If Alex Buckley were here, and he were asked about what he regrets, he would marvel on how Java managed to get all of the defaults wrong.
Yes.
And still become popular, right? So fields are mutable by default. Wrong default. Fields are not private by default. Again, wrong. Classes are extensible by default. Again, wrong. Right? So there were all of these mistakes that we made in the 1.0 days that turned out to be a burden on building reliable code. And somehow there were so many other fantastic things about Java that the bundle of all these things, including these mistakes, were good enough that people continued to want to program in it. And that's pretty remarkable. He would say it in a much funnier way, but.
And in a lovely British accent. Let's look at the questions. Will Valhalla include reified generics? Is it even possible to add it to the JVM without breaking backward compatibility?
Yes, welcome to my world. So, will Valhalla include reified generics? So, because we have the newfound religion of not trying to solve all the world's problems in one release, Valhalla will be delivered over time, and specialization of generics is not going to be in the first version. In the first version, we are most likely to have things like the ability to declare value types, the ability to flatten value types into arrays and other objects, and the ability to generify over values using erasure, so that you can reuse the code that we already have, like array list and hash map, with value types, but not necessarily getting the full benefit of flattening all the way down. If you want to get the benefit of flattening all the way down, then you have to be able to push the type parameters down into the VM to some degree or another. And this is an understood process. Unfortunately, all of the previous attempts at doing so have required a flag day, which is we have to take our existing generics, throw them out, write new ones, and everyone has to switch. And of course, we're never going to ask people to do that. And so the challenge of how you migrate erased generics to be specializable is tricky, but it's doable. And one of the reasons why Valhalla has taken so long is we've spent a significant fraction of the time that we've spent working on it wrapping our heads around exactly what are the migration compatibility constraints of how are we going to migrate ArrayList and Stream and other libraries that people don't want to let go of, and in fact can't let go of because types like list show up in other APIs. So even if we went out and said, you know what, our collections are 20 years old, time for some new ones, let's make some great new collections, that would be a really fun project. And now we'd have these great new collections, and all the Java libraries in the world will still use list and map and set. And so being able to migrate away from the types that we have is another 10-year process. And so we have to figure out how to migrate our existing generic classes to be specializable. And the answer is it can be done. The answer may not be one that makes the questioner happy, because when people say, well, can we have reified generics? They're imagining a world of, rainbows and unicorns and everything is perfect and I have all the performance and all the type information and all the compatibility and, well, you don't get everything, right? So, for example, if there are existing class files out there that instantiate array lists, which is like all of them, well, even if we reified array list, what are these dusty old class files going to do? They have to be able to instantiate an array list of what? Well, that's an array list of erased. And that's fine. We can have a type system where one of the type parameters is the non-instantiable type erased. And some class files which don't know about specialization may instantiate erased generics. And you go to reflect over it and you say, what's the type parameter of this list? And it says, the type parameter is erased. And that's perfectly sound, and we can do that compatibly, and it's probably not what most Twitter questioners think of when they think, are we going to get reification? So the answer is yes, but yes, we can do it. We can do it compatibly. We know how to do it, and it's going to be incredibly cool. And I can't wait to get it done.
10 minutes. Question on Twitter. I'd love to hear your thoughts as architects on Oracle JDK versus Open JDK in an enterprise environment. Well, From an architectural perspective, there's very little to say because they're functionally interchangeable. You can use an Open JDK build, you can use an Oracle JDK build. As of 11, drop it in, use whichever one suits your purposes. But I suspect the questioner wanted to hear a little bit more. So they're functionally interchangeable because we open sourced all of the previously closed features, as Brian mentioned. So that includes not just application class data sharing, but the Z garbage collector, application unit, flight recorder, and Java mission control. So they're drop-in interchangeable. From putting my hypothetical architect pretending to be a business guy hat on, well, the difference is with Open JDK, the difference is basically, well, where are you going to get updates from? Who's going to provide you with security patches? Do you actually want active support, where there's an email address or a phone number you can call up when something goes wrong and get help with your specific issue? So, because of the change in Oracle's licensing over the last year, a number of existing businesses, maybe some new businesses have cropped up, of people who want to sell updates and support on Open JDK builds, and that's great. So you can get a JDK build from one of them. You can get a JDK build from Oracle. You can switch from one to the other. You can choose to pay or not. There are many free providers. There are providers that are building JDKs, and those are coming out of teams that have deep expertise in the code because they've actually been contributing in Open JDK for a long time. So companies, not just Oracle, but companies like Red Hat, SAP, they're doing their own Open JDK builds, and you can get builds from them. There are some others showing up that have, frankly, not that much expertise, and you can get builds from them too. It's your choice. Choose wisely. It's up to you. I'll cover this in a bit more detail in the keynote tomorrow afternoon, but I think that's the gist of it. Architecturally, they're identical. Pick what works according to the support and the license.
They're all derived from the same code base.
Yep.
Hi there. An earlier speaker today talked about migrating to 9, 10, and 11 and about the pitfalls there and some API breaking changes. Java has grown a lot and has deprecated a lot, but hasn't removed a lot. And I think that speaker was critiquing that. I may be wrong, but you may correct me. With this new release cycle, is Java gonna drop more of these deprecated things to make this whole bundle that have grown a lot smaller, getting rid of old stuff that nobody uses anymore?
Okay, so once again, sorry, I'll plug my keynote tomorrow. We've already moved quite a lot, removed quite a lot. In Java 9, we got rid of all the Java EE modules and Corba. They're just gone. We got rid of some additional methods that had been problematic for creating a clean modularization of the platform. We removed further things in 10. We removed further things in 11. I don't know offhand if we removed anything in 12, but we probably did, and we will continue to do so in the future. This is part of the more aggressive stance of making sure the platform is ready for the future. Will we ever remove all of the stupid deprecated methods in AWT that make you do set foo instead of just invoking a bar method? No, probably not, because that would break a lot of code. And in retrospect, most of those methods should never have been deprecated in the first place. That's a different thing. And those tiny deprecated methods, they aren't hurting anybody. They're helping some people. So no, we're not going to take them away. So yeah, we've already moved quite a lot. I have no idea who the speaker was, but if they're saying that Java has never removed anything, their knowledge is a few years out of date.
Things really changed around 9 on this story. So historically, we were reluctant to remove things. And modularity was one of the things that made it easier to remove things. And at the same time, we revamped our processes for describing deprecation, documenting it, identifying whether something is deprecated because it just seems like a bad idea, or because we're actually planning to remove it, and we followed through on those removals. So it has changed quite a bit in the last few years, and we plan to continue to get rid of stuff that is slowing us down from moving forward faster.
Okay, a question from Twitter that I would very much like to answer. Do you plan for Graal VM to be the only VM for Java soon? No. Absolutely not. So let me try. This is a very common confusion. I understand where it comes from. So there's Java in the JDK. We're all familiar with that universe. Graal VM is another product. Right now, it's a derivative of JDK 8. This is coming out of Oracle Labs. It's got some very interesting technology in it. It is not meant to replace Java. Graal VM's big strength as a product is the whole polyglot language story, right? With Graal VM, you can run, Python, R, JavaScript, C, and Ruby, a host of languages, all on top of the same Java virtual machine, with very efficient cross-calling between all of those languages. And so, if that's something that's a benefit to you, then yeah, go check it out. There's no intent on the part of Oracle or anyone else I know to make Graal VM become Java in some sense. I think part of where this confusion comes from is Graal VM contains a whole bunch of interesting technologies. One of the things that's in it is a runtime compiler that is called Graal, just Graal, not Graal VM. So there's that Graal compiler. There's a copy of that in the JDK as of 9, and we use that for ahead-of-time compilation. It's also available as an experimental runtime compiler. It's part of another of our ongoing projects, Metropolis, whose really long-term goal is to write as much of the VM itself in Java as we possibly can. And Graal, the compiler, we see that as the best option available right now to replace the C2 JIT with something written in Java. Is Graal perfect? No, but it's pretty compelling. It exists, already has 10 years of investment, and something like a runtime compiler is extraordinarily complex. It's not something that you write in a couple of years. They generally take around 10 years to mature, and Graal is right around that point. So I think that's probably a source of some of the confusion. So whenever you think about this, I encourage you to remember that Graal is the compiler. Graal VM is a derivative of JDK 8 that contains the Graal compiler and the Truffle AST interpreter and support for all of these languages running in the same process. And that's this problem space that it's aiming for. It is not a replacement for Java. Are we out of time? 2 minutes? Just about 2 minutes. Anybody else in the room? Microphone's right here. Will Java ever include Goetz in the language? No. I think we've already covered quite a few of these.
But it may include continuations.
Sorry?
But it may include continuations.
It may include continuations. Way better than Goetz. Dum, 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 dum.
Last chance.
1 minute warning. Run.
Brave man.
Tick, 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 tick.
Make it a good one.
I'll do my best. You might correct me on this one, but Java exists as Java 9 in a sort of a hybrid state where the class path as well as the module path are acceptable ways of creating an artifact. But is there a sort of a view in the future where the class path will be removed? And if so, when do you see that being relevant?
I've always said the Java class path will be with us until the heat death of the universe. So no, I don't think the class path will ever go away. I look forward to the day when the widely observed best practice in the industry is to run your Java application with everything on the module path and an empty class path. Maybe even someday we'll get to a point where if the class path is not empty, there will be a helpful warning. But there's just so much code out there that is never going to be recompiled in dusty jar files, or archived in deep caches on Haven Central. No, the class path will never go away. All right. Well, thank you very much.